Hey everyone, welcome back. This is lesson 6.5 part D. This is the fourth in our series of 4 for lesson 6.5. The lesson is finding real roots of polynomial equations. Today we're going to be working on the irrational root theorem. All right, so polynomial equations may also have irrational roots. All right, and here we're going to see once again if the polynomial p of x has rational coefficients, and here we go, if a plus b times the square root of c is a root of the polynomial equation p of x and it equals 0, where a and b are rational and the square root of c is irrational, then a minus b square root of c is also a root of p of x equals 0. So let's just take a look at see what that actually means. All right, the irrational root theorem says that irrational roots come in conjugate pairs. For example, if you know that 1 plus the square root of 2 is a root of x to the third minus x squared minus 3x minus 1 equals 0, then you know that 1 minus square root of 2 is also a root. Recall that the real numbers are made up of the rational and irrational numbers. You can use the rational root theorem and the irrational root theorem together to find all of the real roots of p of x equals 0. For example, this question says to identify all of the real roots of this function, which equals 0. So the first thing we'd want to do is use the rational root theorem to identify the possible rational roots. So remember, the rational root says to take the factors of 2, which we said was p, over the factors of the lead coefficient, which is 2, so p over q. So all the factors of 2 over 2, and that's plus or minus, so here they are. P equals 2 and q equals 2. And there are all of our choices that we could try to see if any of those were factors. And we could do long division to work that out. But another thing we could do is go ahead and put it in our calculator. And when we graph it in our calculator, we're going to look at the x-intercept. So here's a picture of what it would look like. And notice, let's see if we can see what all we have here. I'm going to go ahead and put in here. The x-intercepts are located at near negative 0.45, so that's this one, and 0.5, which is right here, and 4.5. Okay, the x-intercept negative 0.45 and 4.45 do not correspond to any of these choices up here. Okay, but we do see that the 0.5, 1/2, is actually here, plus 1/2. Okay, so what are we going to do? How are we going to find the other two? Well, so the first thing we should go ahead and try and do is go ahead and test our rational root of 1/2. And so the way we're going to do that is by setting up synthetic division. So let's go ahead and set that up. Here's our 1/2, and let's set up for our synthetic division. And so first thing we do is bring our 2 straight down, multiply by 1/2. 2 times 1/2 we know is 1. Negative 9 plus 1 is negative 8. Negative 8 times 1/2 is negative 4. 0 plus negative 4 is negative 4. 1/2 times negative 4 is negative 2. And sure enough, we get 0 for our remainder. All right, so now that we've tested the remainder, we see that x minus 1/2 is a factor. All right, so we know so far that the polynomial is going to factor into x minus 1/2 times, and notice this is 2x squared minus 8x minus 4. All right, so step 4, we're going to solve 2x squared minus 8x minus 4 equals 0 to find the remaining roots. Well, the first thing that we could do is go ahead and factor out the greatest common factor, which we see there's a 2 that divides evenly into each of these numbers. So once we do that, we get this equation, 2 times x squared minus 4x minus 2. And the easiest way I know to check and see if I could factor that is make my big X and say, are there two numbers that multiply together to get negative 2, add together to get negative 4? and I can't see any way that we can do that. So we're going to have to try and factor a different way. And so I think that we should try and use the, what am I trying to say? The quadratic formula to identify it. So remember, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so you could fill in your a, b's, and c's. That would be one. This would be your A, B, and C. You can fill that all in. And go ahead, and once you do that, we end up with x equals 2 plus or minus the square root of 6. So the fully factored equation is 2 times x minus 1/2 times, now notice when it said x equals, on the other page we had x equals 2 plus or minus square root of 6. Remember, now that we know that, we have to set it back into our factored form, x minus, and also the x minus 2 minus 6 minus 6, because all of that has to equal 0, just like we did with our 1/2. All right, we actually have to put it back in. So the roots of our problem are going to be 1/2, 2 plus square root of 6, and 2 minus the square root of 6. All right, here's another one to try. You can try this out on your own first if you'd like. Go ahead and turn your video off and give it a try. All right, so when we're asked to identify all the real roots, the first thing we should go ahead and do is use the rational root theorem to identify possible rational roots. And remember, the rational root theorem says to take our last number, which is -4, we're going to have to find all the factors of -4 over all the factors of 2. All right, so we see that P is -4 and Q is 2. And so here are all of our choices that we could choose from. So the next thing we should do is go ahead and graph it in our calculator. That's the easiest thing to see, to take a look at some of the x-intercepts. And so when we do that, we take a look at it, and we can see that x-intercepts are located at or near -1/2. So that would be somewhere around here. -1.2, that would be somewhere around there too. And 3.2, way over here. Now, when we're looking up here at our possible rational roots, we can see that the -1.2 and 3.2 aren't in here. We can't see those at all. But the only one that does is the -0.5, so that's -1/2, which would be right here again. All right, so let's go ahead and find out if that is indeed a factor. Okay, so we're going to test the possible rational root of -1/2. So let's go ahead and do our synthetic division. Go ahead and set it up. Here we go. And let's just remember, bring your 2 straight down. Multiply -1/2 times 2, and we get -1. Add those together is -4. Multiply -1/2 times -4. We get 2. Add those together, -8. -1/2 times -8 is +4. And sure enough, we do have a remainder of 0. So that tells us that it is indeed a factor. So x plus 1/2 is a factor. All right. So the next thing we see so far then is our polynomial factors are going to be x plus 1/2 plus this entire rest of the equation. So the next thing we want to do is go ahead and solve this part of the equation to find the remaining roots. And I can see that there's a common 2 in everything. So I'm going to factor that out. It's the greatest common factor. And now, again, I'm going to look at this equation and see if I can factor that easily. Can I think of 2 numbers that multiply together to get -4 and add together to get -2? And let's see. I don't think that I can, so we're going to use the quadratic formula then to identify the irrational roots. Remember, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, and I've already done it for you here. So I see that x is going to be plus or minus the square root of 5. So what that tells me then is that the fully factored equation is going to be 2 times x plus 1/2 times x minus 1 plus square root of 5 times x minus 1 minus the square root of 5. I might have said that wrong. So our roots are 1/2, and that's actually negative because it's the opposite of what's in here. All right. And then we have positive 1 plus 5, and we also have positive 1 plus square root of 5. And that, my friends, is the end of lesson 6.5. Have a great day, and I'll see you soon.